Okay, so in this lesson, we're going to be doing section 8.2, the trig ratios. In the last lesson, we saw in the last lesson that the side lengths of a right triangle are related to by the Pythagorean theorem. We also saw that there are side length relationships with special right triangles, certain angle measurements. So the question is there a relationship between the angles and the side lengths of any right triangle? And the answer is yes, there is. Here we have the trig functions or trig ratios. This is the relationship between the side lengths of a right triangle and its acute angles. Okay, we're going to be only looking at 3 of the trig functions. There are more than 3, but we're going to only look at 3 of these and some special cases of them. This right here is the sine of angle A. Sine is how you pronounce it. And when you see this, this is how you read it all the time. It is always the sine of angle A. This right here is the cosine of angle A. The cosine of angle A. This is the tangent of angle A. We never read this as the tan A. Don't ever do that. This is the tangent of angle A. That's how you read it. Okay? And this is the relationships for the side lengths. So over in our right triangle over here, we have C is going to be at the, in this particular case, C is at the right angle. The side that is opposite that angle is the hypotenuse, the longest side of a right triangle. The other sides are given names according to which angle you're using as the reference. For example, here's angle A. The side that is next to angle A is called the side adjacent to it. Adjacent means next to, so this is the side adjacent to angle A. And this down here would be the side that is opposite angle A. Opposite from the angle. The opposite to it. But from angle B, those switch roles. From angle B, this is the side that is adjacent to angle B. And this would be the side that is opposite to angle B. Okay, so you have to keep that in mind as you're doing this. Over here, we have the ratio. So the sine of angle A is the length of the side that is opposite, so this length, divided by the length of the hypotenuse. And we abbreviate that with opposite over hypotenuse. The cosine of angle A is the length of the side that is adjacent to angle A, divided by the length of the hypotenuse. Adjacent over hypotenuse. And the tangent is the length of the side that is opposite, divided by the length of the side that is adjacent, or opposite over adjacent. And then to help you remember this little rule is this mnemonic over here called SOHCAHTOA. Sine is the opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is the opposite over adjacent. So this should help you remember the trig rules. Once we have this, we can go and do some problems associated with it. Okay, so I have an example right here. Let me just move over here to my working page. So here is a right triangle, and I want to find the sine, the cosine, and the tangent ratios for angle F. Okay, so to do that, start with the sine of angle F. So the sine of angle F. The sine is the opposite, so let's put the SOHCAHTOA up here. So we can remember our rule. So the sine is the opposite length over the hypotenuse. So I'm going to have a fraction or ratio over here. Here's angle F. The side that is opposite angle F is the one farthest away from us, all the way across. So that is the side opposite. Its length is 12. What is the hypotenuse? So it's opposite over hypotenuse. The hypotenuse length is 15. So it's 12 over 15. That is the ratio, but you need to reduce it. We have a common factor of 3, so we get 4/5, and that is the sine of angle F, or fifths. What is the cosine of angle F? Again, I know it's a ratio. It is the adjacent length divided by the hypotenuse. Here's angle F. This is the side that is adjacent, so that is a 9. And the hypotenuse we still know to be 15. And again, we have a common factor of 3, so this is 3 over 5. And there's the ratio for the cosine. For the tangent of angle F, that is the opposite length divided by the adjacent length. So the opposite length is 12. The adjacent length is 9 over 9. And when we reduce that, we get 4/3. And those are the three trig ratios. Always make sure your fractions are reduced all the way down. And if we do it to a decimal, if you need to do something to a decimal, then it will always be rounded to 3 decimal places, unless told otherwise. So here I have an example that's kind of related to what we did last time. We still have the 30, 60, 90 here. Once we see that, and I find any of these values, okay, I forgot to put this right here, is 9. So we can do this using the same technique we had before because it is a 30, 60, 90. Okay. We can also use the trig ratios to figure this stuff out. All right, so let me go ahead and do it with the 30, 60, 90. So we can see clearly that this is the 9 is on the long side. This is the short side. So we always want to find the short side. So to go from here to here, I need to divide by the square root of 3. So I know that FH is 9 divided by the square root of 3. And I know that the hypotenuse y here is twice that number. So I'll just take this number here and times it by 9. Sorry, by 2. And then you get 18 over the square root of 3. We want to rationalize that. This is what we did last time. And so I end up with y equals 18 times the square root of 3 divided by 3, which reduces. 3 goes to 18. So there's my answer. Okay. Now, if I use trig ratios in this particular problem, I can use any one of these two angles here. So let's say I take angle G. This angle is 30 degrees. This information that was given to me, this side is adjacent to angle G, and this is the hypotenuse of this triangle. So adjacent and hypotenuse would be the cosine ratio. So I would write the cosine of angle G, which is 30 degrees, must be equal to adjacent over hypotenuse. Okay, and so then I can then take this is a proportion, I can cross multiply and solve for y. You want to get y equals, so I can multiply those two numbers together and those together, giving me y times the cosine of 30 degrees equals 9. Divide by this cosine of 30 because it is just a number. 9 divided by the cosine of 30 degrees. And so now I can get an approximate calculator value from this. Later on, we'll learn what this value actually is. I'll tell you in just a moment. But if we use our calculator, you want to make sure you're in degree mode on your calculator. So you come up here to the little thing right there on the end, that little gear-looking thing, and see that it was in degree mode. If it's in a different mode, you'll have to change it to the degree mode. And then I can just start typing this in. It's a fraction, so I'll use the fraction button. And I'll type 9, and then down here I'll type in the cosine, which is right here in the trigs. So you see there's a button called trig right there. And all the trig functions that we're going to be using, there's the cosine, and you just type in 30 degrees. And so then we hit Control Enter to get a decimal. And there it is as a decimal. So it'll be 10.392 rounded to 3 places. Okay. And so that is my answer right there. Now, this is an exact answer. This is an approximate answer. But are they the same answer? Well, to do that, let's just type in 6 times the square root of 3. And sure enough, you can see that it's exactly the same number. Okay. In future classes, I'll show you how to get this answer as an exact answer without a calculator, but that will be for another class. So right now, if you have to do something like this, you just round your answers to 3 decimal places, and you'll be fine. So the second part of this question is kind of related to what we did over here, and it is, how can you write an equivalent expression for the cosine of 70 degrees using sine? And I also want to write an equivalent expression for the sine of 34 using only cosine. And so how can I do that? Well, let's come down here and let's draw the new triangles. Here's my right angle. Here's A, C, and B. This is side A. This is side B. This is side C, because we don't have any numbers to associate with this. I know this angle is 20 degrees and this angle is 70 degrees. Okay? So for the first thing here, let's find the expression for the cosine of 70. So 70 is this angle up here. The cosine is adjacent over hypotenuse. So the cosine of 70 degrees is the adjacent over the hypotenuse, so B over C. Okay? And what they're trying to get you to see here is how these two angles are related in these trig ratios. Okay? So if B over C is the answer to the cosine of 70, can I get B over C to be the answer to something that starts with sine? Well, the sine is opposite over hypotenuse. So from angle B, that's the opposite side, and C is still the hypotenuse. So if I do it from the other side, the other angle, I get the exact same value. So what this is telling you is that these two answers are exactly the same answer. Okay, and it's because they are complements. Okay, they're complementary angles. They add up to 90 degrees. These are complementary angles. Okay, so in the triangles, that's how that works. Okay, so you try and, given whatever the given information is, you match it to one of the trig ratios, and some person can use the cosine of one angle and the other can use the sine of the other angle, and you'll get the same answer, and it's all correct. So with that in mind, if I have the sine, if I do another triangle, A, C, and B, right angle, and I use an angle 34 degrees, then the sine of 34 degrees must be equal to what? Well, if this is 34, then we can find the complement to it over here, 56, and I can say that this is the same thing as the cosine of 56 degrees, and they are both B over C, according to our triangle. Okay, so that's how that works. Let's look at another example that we have. This is more real life kind of scenario, and it kind of leads to where we need to be going. So if I have a problem like this, this is a real life scenario problem. A plane climbs at 5 degrees and flies for 20 miles through the air as it climbs. What is the altitude of the airplane to the nearest foot? In a situation like this, and as we go in through these problems in more detail, the most important part of your word problem is always to draw and label a picture that represents the situation. And the best way to draw a picture is to be part of the picture. So imagine yourself seeing this. What does it look like? And try and draw triangles that match what you're trying to see. For example, if a plane is flying, going to take off from the airport, it's flying, well, it started on the ground, so you need to draw the ground. The plane is going in one direction. You can draw a plane if you want, but you don't need to. It just adds clutter. And it starts climbing at a 5-degree angle. That means this is 5 degrees. And it keeps on going, it keeps on going. And when I go and have traveled 20 miles in the air, so that's this length right here is 20 miles, I want to know how high it is. That's an altitude. Altitudes are always perpendicular to the ground. Okay? And since it's a height or altitude, we usually use the letter H for height. So this gives us our picture that I can then use and try and find a trig ratio to help me solve this problem out. So based off of what I see from this angle, H is the opposite side. The 20 is the hypotenuse. So opposite and hypotenuse is the sine function. So the sine of angle 5 degrees is the opposite over the hypotenuse. And that gives me my equation. Okay, you need to show me this. This is a mandatory step in this process. The next step is to take this and cross multiply and do that and solve for h. So as I multiply in the diagonal sense, the cross multiplication, solving for h, I will get h equals 20 times the sine of 5 degrees. Always put the trig ratio last. So write it as 20 times the sine of 5 degrees. Showing me what h equals is another mandatory step. The last step here in this process is you want to give me an approximate value of what h is, because as much as we would like to know, this does not make sense to us as a height. So we need to find this as a value that we can make sense of. So we use our calculator and we type this in. Remember, we make sure you're always in degree mode when you do this. You just type 20 times the trig ratios, the sine of 5. Okay, Control Enter, and you get that number right there. Now we're not going to round that number off because we're not done yet. Only round off your very final answer. Until then, don't round things off. So you can write it off as 1.74385,495. Now normally I wouldn't write it all down. I will keep it in my calculator because I'm going to do more with it, but usually I do just kind of round this off briefly. But then when I use my next calculations, I'll use the exact value from the calculator that was given. So the reason why I needed to pause on this one is because what does this number represent? So yes, it represents the height, but what are the units on this number? Because it says round your answer to the nearest foot. Is this the number of feet we have? Is it 1.7 feet? Is this plane 2 feet off on the ground? Well, no, that doesn't make sense. This unit was miles, so that means miles is in the units in this problem. This is 1.7 miles. So I need to change this to foot. So to change something to foot is to write this number as an equivalent value, but in a different unit. To do that, we need to know how many feet are in a mile. So if you don't know this, here it is. It is a required number to know because we will do so many problems with it. This is a conversion ratio. These are equivalent values. Okay? So just like in fractions, when I want to change a fraction to an equivalent fraction with a different denominator, we multiply the top and bottom by the same number. We're going to do the same thing here. I have this number, 1.74311485495 miles, and I'm going to multiply it by a fraction that is equivalent to 1. And I'm going to write it in such a way that the units are going to change. Here is my fraction right here. 1 mile is 5,280 feet. I have this many miles. So I want the miles to basically drop out. Kind of like a number, how we can reduce. So that means this is on top, so I want the 1 mile on the bottom, which means the 5,280 feet will be on top. Remember, this is just a ratio that is equivalent to 1. The only thing we're doing here is basically changing units from miles to feet. This mile unit and this mile unit kind of reduce out like a number would, leaving only the units for feet. And so all I have to do to find out how many feet this is going to be is simply multiply these two numbers together. Since the one number is already in my calculator, I don't need to do anything other than to simply type times 5,280. Then I get this number, and this is the number you're going to round off to the nearest foot, which means this answer is going to be approximately 9,204 feet. to the nearest foot. Because it was 9,203.6, so it'd be rounds up to the nearest 4. So that would be the answer to this problem. Okay? Now, the next thing we want to talk about is how do I handle this question that's coming up? How do I find an angle measure? All right. The trig ratios are used to help us find side lengths and use the sides and stuff for angles that we're given. So if I'm not given an angle and I need to find an angle, then I need to use what are called the inverse trig ratios. And you probably saw this in the calculator. The sign with the little -1 at the top here, like a power. This symbol means inverse function. The inverse functions are used to find the angle measurements. This is what you use. Now, we will explore this in a later class in more detail, but for now, you just need to know what its use is. So if I have the cosine of angle A is the adjacent over hypotenuse, I have that trig ratio, and I want to know what angle A is, then the inverse cosine on the cosine undo each other. Just like if I add and then subtract the same number, I've undone that operation. If I multiply and then divide, I am undoing that operation. This is an operation on angle A. The inverse of that operation will undo it. So the cosine inverse on the cosine, in many cases, drop out and leave me just this angle, A. But whatever I do to one side, I must do to the other side. So the cosine inverse of the cosine of A is A, and the cosine inverse of 3/5 is the cosine inverse of 3/5. This is the exact answer. Use your calculator, and you can type this in, and you'll get your approximate answer. Works for all the functions that you have the inverse for. This is how you display it. This is how you work it out. You can also have used the fact that these are complementary angles. So once I have angle A, I could just simply subtract it from 90, and I would have gotten this answer over here. But I also wanted just to show you how that's done. So with that in mind, let's do an example over here. We're going to do this problem right here. We want to find the measurement of angle P. So here's angle P. So I have these two numbers, and what numbers are in relationship with these? From angle P, this is the side that is opposite. This is the side that is adjacent. So the trig ratio that has opposite and adjacent in it is the tangent. So the tangent of angle P is the opposite over the adjacent. And that's how you get your trig equation. I want to undo the tangent on this angle P, so I'm going to take the inverse tangent of the tangent, and then I do the same thing on this side, so the equation stays balanced. These things drop out, and I'm left with just angle P. And then I can have angle P is the inverse tangent of 2/3. I can use my calculator then to work this out. So we type it in. Let me show you this one typed in. So we're going to go in here to trig, and you'll see that the inverse ones are all in the bottom row. Inverse tangent, and I usually use the fraction button, 2/3. Okay, and then I can hit Control Enter, and it gives me this answer over here. And you should round everything off to 3 decimal places if you would, please, unless told otherwise. That is your standard default setting. Sometimes the problem will tell you to round it off to 1 or 2 or whatever. Do what it tells you if it tells you, but if it doesn't tell you, always round to 3 decimal places as a default setting. And then, so there's the angle P. I got two options for the next one. I can go through and I can just use it as a complement. So in other words, the measurement of angle Q, this is the measurement of angle P of Q is 90 minus this number. And so then the measurement of angle Q is approximately, since this is an approximate value, is approximately 56,310 degrees. So there's that one, and there's that one. I could also have done a trig function for Q. The tangent of Q is the opposite over the adjacent. So 3/2. and I could have solved this problem out and gotten the same answer. Okay, so you would do this, and then Q, the measured angle Q is equal to the inverse tangent of 3 over 2, and it's approximately, on the calculator, you'll see you're going to get exactly the same number. So I could have done it that way or that way, both of which are correct. So we'll be doing more problems like this in class as soon as this video.